Hello students, so welcome back to my video lecture on chapter 3 of 11th standard, that is classification of elements and periodicity in properties. Well, we were solving multiple choice questions on this chapter. Let us continue doing it. Yes, so I think in the previous previous video I think we have solved problems up to 56, I guess. So I think this was the last problem in the previous video, and the answer for this was option C, 6s to 6p6, 6s to 6p6. Now let us continue with the next question. What is the next question? The next question is like this: which of the elements whose atomic number are given below cannot be accommodated in the present set of the long form of periodic table? Which of the elements whose atomic numbers are given below cannot be accommodated in the present set of long form of periodic table? Look here, see, the long form of periodic table it is designed for 118 elements. That means we have designed the long form of periodic table for the element up to atomic number 118, up to atomic number 118. We have designed our periodic table only for the elements up to atomic number 118, because right now we have discovered only 118 elements. Out of 118 elements, 114 elements are naturally occurring, and 4 elements are man-made. They are man-made, or it is artificially synthesized. So right now we have only 118 elements, and our entire periodic table is completely full with the elements up to atomic number 118. But if you want to accommodate any element with atomic number greater than 118, no, it cannot be accommodated in our long form of periodic table. If you can observe the periodic table here, so here the last element is ognesium, so whose atomic number is 118. This is the last element of the periodic table. If you want to accommodate any element with atomic number more than 118, no, it cannot be accommodated in this. We call this entire periodic table as long form of periodic table. We call it as long form of periodic table. Long form of periodic table. So this long form of periodic table is designed only for up to this element, that is atomic number 118. Beyond that, no, we cannot accommodate those elements in this long form of periodic table. Now let us go back to the question. So according to the question, so it is we can accommodate only the elements up to what? Atomic number 118. But beyond 118, no, we can't. Can we accommodate 107? Yes, we can. Can we accommodate 102? Yes, we can. But can we accommodate the element with atomic number 126? No, we cannot. We cannot accommodate the element with atomic number 126 in our long form of periodic table. We can't do it because it exceeds 118. So the answer for this question is option C. Option C. Yes, that's correct. Next question. Elements with atomic number 35, 53 and 85 are all. The elements with atomic number 35, 53 and 85 are all what? Are they noble gases or halogens or heavy metals or light metals? So if you consider noble gases, we know noble gases starts from what? Helium, neon, argon, krypton, xenon and radon. What is the atomic number of helium? Atomic number of helium is 2. Just add 8 to this. 2 plus 8 is 10. 10 plus 8 is 18. 18 plus 18 is 36. 36 plus 18. 36 plus 18 is 54. 54 plus 32 is 86. Look at here, the noble gases will have the atomic number 2, 10, 18, 36, 54 and 86. 54 and 86. But the elements with the atomic number 35, 53 and 85, they do not belong to what? They do not belong to noble gases. Okay. Don't you think the atomic numbers 35, 53 and 85, they come before noble gases, just before noble gases? Because okay, successive groups will differ by just one atomic number. If I go from group 1 to group 2, the elements of group 2 okay, will differ by an atomic number 1 from group 1. Like that, group 2 to group 3, the every successive okay, groups will differ by atomic number by a factor of 1. Okay, so like this, so they have given 35, 53, 85. We have 36, 54, 86. 36, 54, 86. Don't you think those elements, they come just before noble gases? They come just before noble gases. Which is the group which comes just before noble gases? It is halogen family, isn't it? Halogen family. Okay, correct? Okay. Can you name the elements of halogen family? Yeah, we have fluorine, chlorine, bromine, iodine and astatine. Fluorine, chlorine, bromine, iodine and astatine. Atomic number of fluorine is 9, 17, 35, 53 and 85. Look at here, 35, 53, 85. 35 is bromine, 53 is iodine and 85 is astatine. 85 is astatine. Therefore, these elements belong to which one? Halogens. They belong to halogens. Heavy metals means okay, D block elements and F block elements. D block elements and F block elements. Whereas light metal means okay, alkali metals and alkaline earth metals. Alkaline earth metals. Alkali metals and alkaline earth metals, they are called as light metals. No, okay, the elements with those atomic number, they are not heavy metals, they are not light metals, or they are not noble gases. They are what? Halogens. Which is the element with atomic number 35? Bromine. 53 iodine, okay, and 85 it is astatine. So the correct answer is option B. Yes. Okay, next question, students. Next question. The electronic configurations of 4 elements, just a minute. Okay, yeah. The electronic configurations of 4 elements A, B, C and D are given below. Okay, for 4 elements, the electronic configurations are of 4 elements A, B, C and D. Okay, for the element A, the electronic configuration is 1s2, 2s2, 2p6. For element B, it is 1s2, 2s2, 2p4. For element C, 1s2, 2s2, 2p6, 3s1. For element D, 1s2, 2s2, 2p5. Now, which of the following is the correct order of increasing tendency to gain electrons? Increasing tendency to gain electrons. Okay, what is the correct order of increasing tendency to gain electrons? Tendency to gain electrons means it is talking about okay, electron affinity or electronegativity. Electron affinity or electronegativity. Tendency to gain electrons means electron affinity or electronegativity. See students, now just go with the options. Okay, element A has the electronic configuration 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Don't you think it is a stable configuration? Yes, okay, it is a stable, it has already attained octet configuration, it has an octet configuration. Okay, octet configuration means it is stable. So element A is already stable. We know okay, element A, since it is already stable, it has no tendency either to lose electrons or to gain electrons, because it is already stable. It has no tendency to lose electrons or to gain electrons. Hence, can I say, okay, element A has least tendency to gain electrons? Yes. Because why it has least tendency to gain electrons? Since it is already stable. Okay, correct. Now, if I go with option D, element D, okay, just look at element D. Its electronic configuration is 1s2, 2s2, 2p5. If it just gets one electron, if it can gain one electron, its electronic configuration is going to be 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. On acquiring just one electron, it will attain the noble gas configuration. Okay, so element D is just short of one electron to attain the nearest noble gas configuration. Therefore, can I say that D has highest tendency to acquire the electron or the highest tendency to gain the electron? Yeah, yes. So element A has least tendency to gain electrons and element D has highest tendency to gain electron. Why element A has least tendency to gain electron? Because it's already stable. Why element D has highest tendency to gain electron? Because on gaining one electron, it will attain the nearest noble gas configuration. Yes, therefore D has highest tendency. Now if you can compare C and B, observe C here. See, its electronic configuration is 1s2, 2s2, 2p6, 3s1. No doubt it has the tendency to gain electron. Upon gaining one electron, it becomes 3s2. The electronic configuration is going to become 3s2. But rather than gaining one electron, if element C will lose this electron, it is going to attain the nearest noble gas configuration. Correct? Rather than gaining electron, if it loses one electron, if it loses this outermost electron, then it's going to attain the nearest noble gas configuration. Therefore, can I say that now C, it has the tendency to gain electron, but more than gaining electron, it has more tendency to lose electron, because on losing one electron, it will attain the nearest noble gas configuration. But observe B. If you compare B, of course it will gain one electron. If it gains one electron, it becomes what? 1s2, 2s2, 2p5. On gaining one more electron, it's going to become 1s2, 2s2, 2p6. Yes, okay. Element B has a tendency to gain 2 electrons. It has to gain 2 electrons. So the tendency to gain electrons is more for B than for C. Is it correct? C, instead of gaining electron, it has a tendency to lose electron. So what is the correct answer? The correct order is, yeah, okay. D has more tendency to gain one electron to attain the noble gas configuration than B. Okay, B has more electron gain tendency than C. C has more electron gaining tendency than A. A has least tendency. D has highest tendency. So what is the correct answer for this? D is more than B, B is more than C, C is more than A. Yes, of course, it is option A. Is that simple? Okay, correct? Yes, exactly. Now, let us move on to the next question. Yes. Next question says, which of the following statements are correct? Okay, which of the following statements are correct? Just a minute. Yes, yeah, which of the following statements are correct? Okay, so helium has the highest first ionization enthalpy in the periodic table. Chlorine has less negative electron gain enthalpy than fluorine. Mercury and bromine are liquids at room temperature. In any period, atomic radius of alkali metals is the highest. Okay. First, if you take up the first option, which of the following statements are correct? That means for this question, you can have multiple answers. It's telling are correct. It is not asking is correct. Are correct. So that means you can have multiple choice question. It's a multiple choice question. Okay. Yeah, I mean multiple answer correct. No, for this we can have multiple answers. Okay, so helium as the first highest ionization enthalpy in the periodic table. Yeah, helium is a noble gas. Helium is a noble gas. Of course, noble gases have extremely high ionization enthalpy. They have the highest of all. They have the highest ionization enthalpy of all other elements in the periodic table. Okay, now noble gases means helium, neon, argon, krypton, xenon and radon. Helium, neon, argon, krypton, xenon and radon. Okay, so of course these are all the noble gases. Noble gases have extremely high ionization enthalpy. But among noble gases, which one has highest ionization enthalpy? Of course it is helium, because down the group ionization enthalpy decreases. Down the group ionization enthalpy decreases. Hence helium has highest ionization enthalpy. Therefore option A is correct. Yeah, this is correct. Chlorine has less negative electron gain enthalpy than fluorine. Let us take halogen family. We have fluorine, chlorine, bromine, iodine and astatine. Down the group electron gain enthalpy should decrease. Correct? Okay. Down the group electron gain enthalpy should decrease. But I have told you that there is an exception to this rule. There is an exception to this rule. Okay, down the group electron gain enthalpy should decrease, but from fluorine to chlorine electron gain enthalpy increases and then it decreases. And then it decreases, isn't it? Okay, from fluorine to chlorine electron gain enthalpy increases. That means chlorine has more negative electron gain enthalpy than fluorine. Hence option B is incorrect. Correct? Okay, yes. So chlorine should have more negative electron gain enthalpy than fluorine. This is an exception, correct? So, but according to this option, chlorine has less negative electron gain enthalpy than fluorine, which is obviously wrong. Okay, what is the next question? Next option. Mercury and bromine are liquids at room temperature. Exactly. Mercury is a liquid metal. Bromine is a liquid non-metal. They both exist at room temperature. Yeah. Mercury is a liquid metal. Bromine is a liquid non-metal. Yes, this is also correct. Yeah. In any period, atomic radii of alkali metals is highest. In any period, atomic radii of alkali metals is highest. Alkali metals belongs to group 1, isn't it? Group 1. Okay, alkali metals. Alkali metals belong to group 1. Okay, so it is after group 1 if you go with from group 1 to group 2, group 3, group 4, group 5, group 6 up to group 18, what will happen to the atomic radius? Atomic radius decreases along the period. Along the period atomic radius decreases. That means group 1 elements have highest atomic radii. Because from group 1 to group 2 it decreases, group 2 to group 3 decreases. So along the period atomic radii decreases. Therefore can I say group 1, that is alkali metals, have highest atomic radius? Yeah. Therefore option D is also correct. Option D is also correct. Okay. So which of the following statements that are correct? It is A, C and D. A, C and D. Any doubts? Okay. That's exactly. Yes. I'll move on to the next question. What's the next question? Okay, just a minute. Okay, I'm just checking out the time. Okay, which of the following is not a merit of Mendelis periodic table? Okay, which of the following is not a merit of Mendelis periodic table? Mendelis periodic table. Okay, read out the options. It helped in correcting the atomic masses of some of the elements. He predicted the properties of some of the undiscovered elements and left gaps for them. He framed the periodic table with vertical and horizontal columns and gave shape to it. He gave separate places to the isotopes of the periodic table. Look at the last option. He gave separate places to isotopes in his periodic table. If you have read, okay, yeah, the dozens of Mendelis periodic table, that is the merits and demerits of the Mendelis periodic table. By looking at the option itself, you will say that option D is one of the demerits of Mendelis periodic table. It's the most famous demerits of Mendelis periodic periodic table. Okay, yes, one of the most famous demerit. Okay, demerit. Actually, Mendelis, yes, he arranged the elements. He has arranged the elements in the increasing order of atomic mass. Increasing order of atomic mass or atomic weight. Atomic mass or atomic weight. How? In different horizontal rows. In different horizontal rows and vertical columns. Vertical columns. Okay, in different horizontal rows and vertical columns. I have the Mendelis periodic table. I'll show it to you now. Okay, based upon that we'll decide the rest of the things. Okay, look at here. I have Mendelis periodic table. I have brought it for you. Okay, see this. This is the Mendelis periodic table. Look at here. He has arranged the elements in different horizontal rows and vertical columns in the increasing order of atomic mass. Look here. Hydrogen 1.008, lithium, okay, 6.939, beryllium 9.012. What are all this? They are all the atomic masses of different elements. So he has arranged the elements in the increasing order of atomic mass. Increasing order of atomic mass in different horizontal rows and vertical columns. Even though he has arranged the elements in the increasing order of atomic mass, he didn't consider any isotopes in the periodic table. For example, can you name the isotopes of hydrogen? The different isotopes of hydrogen are protium, deuterium and tritium. Is that correct? The different isotopes of hydrogen are, okay, protium, deuterium and tritium. So protium, the atomic mass of protium is 1, atomic mass of deuterium is 2, the atomic mass of tritium is 3. They are different atomic masses. Even they, they would have been placed in the periodic table, but Mendelis did not place any isotopes in the periodic table. That is one of the demerits of Mendelis periodic table. Yeah, let us go back. Okay. So what is the question? Yes. Okay. So which of the following is not a merit of Mendelis periodic table? Yeah, it is option D. It is not a merit. It's a demerit of Mendelis periodic table. Okay. So 525 close marking. It is one of the demerit of Mendelis periodic table. Okay, demerit of Mendelis periodic table. Okay, yeah, next question, students. Okay, the question says an element X belongs to 4th period and 15th group. An element X belongs to 4th period and 15th group of the periodic table. Which one of the following is true regarding the outer electronic configuration of X? Okay, so he has given an element X. So he is telling element X belongs to 4th period, okay, and 15th group. 4th period and 15th group. Okay, an element X belongs to 4th period and 15th group. So if it belongs to 15th group is nothing but what? 15th group. So you should have an idea. 13th group means boron family. Okay. 14th group means carbon family. Okay, carbon family. Okay. 15th group means nitrogen family. 15th group means what? Nitrogen family. Are you getting my point? 13th group means boron family. 15th group means carbon family, 14th group means carbon family, 15th group means nitrogen family. So he is telling that the element belongs to 15th group. The element X belongs to what? 15th group. 15th group means nitrogen family. What is the general outer electronic configuration of nitrogen family? Yeah, it is Ns2 Np3. Okay, see this. For boron family, it is Ns2 Np1. For carbon family, Ns2 Np2. Okay, for nitrogen family NS2NP3. Okay, for next family NS2NP4, that is oxygen family. Okay, then halogen family NS2NP5. Okay, for noble gases it is NS2NP6. So the general outer electronic configuration for nitrogen family is NS2NP3. NS2NP3, and is also telling that the element X belongs to fourth period. I have clearly told you period number indicates what? The value of n, isn't it? If the period number is 4, what is the value of n? N is equal to what? 4. If the period number is period number indicates the value of n. So the element X belongs to fourth period, that means n value is 4. Therefore, what will be the general outer electronic configuration of X? It has to be 4s2 4p3. The general outer electronic configuration of the element X has to be 4s2 4p3. Now go with the questions. Okay, the option says it has partially filled d orbitals and completely filled s orbitals. No, there are no d orbitals at all. Let us not worry about it. Okay, so it has completely filled s orbitals and completely filled p orbitals. No, it has completely filled s orbitals but half filled p orbitals. It has completely filled s orbitals but half filled p orbitals. It has completely filled s orbitals and half filled p orbitals. Therefore, the correct option should be option C, isn't it? Okay, did you understand? Fourth period, 15th group. 15th group, nitrogen family. General outer electronic configuration, NS2NP3. Fourth period means n value is 4. Therefore, it should be 4s2 4p3. Okay, completely filled s orbital but half filled p orbitals. Yeah, so the answer is option C, no doubt in it. Okay, yes. Next question. Okay, yeah. Which of the following transitions will involve maximum amount of energy? Which of the following transitions will involve maximum amount of energy? It is M giving rise to M plus an electron, M minus gives M plus 2 electrons, M2 plus gives rise to M3 plus electron, or M plus gives rise to M2 plus electron. Which of the following transition will involve maximum amount of energy? So students, you should understand, if I have to remove an electron from an element M, to make it is M plus, I should give energy, isn't it? That energy is called as what? Ionization energy, correct? Okay, so if I give certain amount of energy to this element M, it will lose electron and it forms M plus. But look here, when the element M gains energy, it loses electron and forms M plus. When it forms M plus, the effective nuclear charge of this M plus will increase. Okay, the effective nuclear charge. What do you mean by effective nuclear charge? Effective nuclear charge means it is the force of attraction between the nucleus and the last electron. Okay, the force of attraction between the nucleus and the last electron is called as effective nuclear charge. So when I remove an electron from an atom, to form an ion, the effective nuclear charge of this ion will be very high. That is, the last electron will be tightly bound to the nucleus after removing an electron in this ion. Now, from this ion, again if I have to remove electron to form M2 plus, okay, I should supply more energy. Because, on forming M plus, it has more effective nuclear charge. Are you able to understand? Upon losing one electron to form M plus, effective nuclear charge has increased. It has more effective nuclear charge. More the effective nuclear charge, more energy you have to supply to remove the last electron. Now, no doubt, I have supplied more energy. Let me call that energy of this transition as E1, and let me call the energy of this transition as E2. Of course, E2 is more than E1. Yes, I have to supply more energy. Same element. but it is in the ionic form. It has lost one electron and it has formed M plus. On losing one electron to form M plus, its effective nuclear charge has increased. So since its effective nuclear charge is increased, I have to supply more energy, okay. Therefore E2 is greater than E1. Now, okay, when this M plus loses one electron to form M2 plus, again the effective nuclear charge in this, okay, M2 plus will be very high. Okay, so this has highest effective nuclear charge. Now if I have to remove one more electron from this ion to form M3 plus, then I have to supply very high energy, that is E3. That means E3 is very much greater than E2, which is greater than what? E1. Okay, my conclusion is, when an atom lose an electron and forms what? Cation. Okay, its effective nuclear charge increases. Okay, increases. Please note this point. Okay, so the effective nuclear charge of M2 plus is more than the effective nuclear charge of M plus, which is more than the effective nuclear charge of M. That means it will be very difficult to remove an electron from M2 plus rather than M plus, rather than M. Okay, so coming on to the question, which of the following transition will involve maximum amount of energy? Don't you think it is this? Yes, because okay, when M plus loses an electron to form M2 plus, its effective nuclear charge will be very high. Okay, since its effective nuclear charge is very high, we have to supply more and more energy. Therefore, this transition will accompany with what? Maximum amount of energy. So which of the following transitions will involve maximum amount of energy? It is M2 plus loses an electron to form M3 plus. Okay, yes.